Hi, I'm Oliver Gao. I'm the director of Cornell Systems Engineering Program, and I have been conducting this what I call system conversation series with our invited speakers to the Israel Seminar Series. So today we are very delighted to have Dr. Kristan Reed, and who is actually an assistant professor of dairy cattle nutrition in the animal science department at Cornell University. Her research aims to improve dairy production, efficiency, and sustainability through development and use of models that simulate the behavior of dairy farming systems under diverse biological, environmental, and management conditions. And apparently, this is a very nice system topic. So, Kristan, welcome to these system conversations. So, I briefly introduced you, but when I was looking at your research, and also, I also visited your website, I think you have really a very broad background, kind of covering, linking all these different aspects into your system research of these kind of dairy systems. So, I think not only me, but I think in our audience, we would love to hear more about yourself, your research, and your career development. How do you go, from a PhD, from your PhD study where usually things are probably pretty much narrowed down, and then to this point you are looking at this dairy system from a holistic point of view.
So, as you mentioned, in PhD study, the nature of the PhD is very specific often. And so during my time at UC Davis, I was focusing kind of on the animal as a system, and within the animal even sometimes an organ system, so the digestive system or the rumen, which is the stomach of the cow. Studying how different feeds will impact the efficiency of the animal, and different stages of the animal's life will impact the efficiency of converting feeds into milk, which is the product that we want from dairy production, right? And so during my time there, I think what I gained that has been most beneficial to my career development is an understanding of different modeling techniques and ways that we can translate biological systems into mathematical and computer simulation models to then help advance our understanding of those systems. And after my graduate work, I was really fortunate to get a postdoc opportunity in Madison at the U.S. Dairy Forage Research Center, which is part of the USDA's Agricultural Research Services. And in that opportunity, the project for that postdoc was to assess dairy farm system nitrogen efficiency. And I was fortunate enough to work under a soil scientist, and that soil scientist, being at the Dairy Forage Center, was still focused on dairy production, and so was kind of familiar with the dairy farm from the animal side, but I really gained an understanding of how we connect those two basic parts of the dairy farm system, being what happens in the barn, feeding and caring for the animals, and then managing and caring for the fields. And so I really had a education on soil dynamics and soil nitrogen dynamics, especially because we're focusing on nitrogen there. But during my time there, I was supposed to be using some existing models of dairy nutrient cycling. And what we found was that the current models really are inadequate to represent the systems, and inadequate to answer the questions that we wanted to answer. And then in speaking with other investigators at different institutions, we found that they had come across the same problem, that the models that were available or are available aren't meeting their needs. And so we gathered a group of researchers that were interested in using this kind of dairy systems model, and have started now I think we've been working together for over 2 years now, working towards a new dairy systems model to simulate that nutrient cycling and the connections between the barn and the field and manure management, and to be able to address some of these research questions, but also their industry challenges, because this is a really important industry in the U.S. in terms of its economic contribution, but also in its contribution to human nutrition.
I can see that you say that in the evolution of your research, like in your PhD, you look at a cow as a system.
Mm-hmm.
And then, of course, you could look into the organs of a cow, and then how all these things are going to be related to the outcome. For example, milk production of a cow, and then you move on to medicine, where you look at the dairy system, which is no longer an individual cow, but it's kind of the living environment of the cow, right? So this is really a very nice evolution. So it basically says one of the key features that we look at systems is kind of the scale. I can think it as a scale of changing from a cow to a whole dairy farm or dairy system. And when we talk about this, and also you can see that it's this dairy, of course, the farm production, and that will impact human health and the societal health. And in addition, even the animal health itself on the farm. This is probably not a very not a perfect analogy, but this kind of reminds me, because for my research, when I was trying to look at human health and what factors affect human health, you can see that now our healthcare system, each year, I think we spend about 18% or 70% of the national GDP for healthcare system. But but that money is spent on taking care of people after people are sick, right? Of course, and then how people get sick, it's now and then, and that lead me to think about the living environment, actually the built environment, the urban systems where people live, have such an important impact on the health. Now coming back into the cow production and the human performance, and then the urban environment where humans live, and the dairy system, the farming environment where the cows live. So I think there is a lot of very good similarities. So when we talk about this dairy system model, do you want to, of course, probably you will talk about in your talk, but would you like to briefly talk about what are included in this dairy systems model, and why those components?
Yeah, so I appreciate the analogy, and I think it's a very good one that you made. I'll just say, because there are interactions between the dairy cow's environment and its health, which then impact its production. And so one of the goals of our model is to be able to put together those interactions in a meaningful way, and because there's a lot of information, a lot of research coming out and being produced every year, but also a rich history of information about things that influence herd and cow health, but they haven't ever really been put together in a way where you can understand how that impacts the bigger picture. And so going back to your question of what's going to be included, we've broken down the farm system into 4 major components, looking at the barn, the manure management system, the fields, which would include both soil nutrient cycling and then crop growth, and then feed storage. So on farms, they feed, and the process is called ensiling. So there's these large fermentation storage areas where the nutrient composition of feeds is changing over time, and so that's a very dynamic system and complicated system in itself. And so so from the barn to the manure to the soil and fields and to the feed storage. And that is the foundation of the model, and the objective is to simulate nutrient cycling within each system, so that number one, you have a mass balance, and you can account for where all of the nutrients are going on a farm under different management systems. But also to understand the interactions between those parts of the system. For example, we know that the quality of the feeds that are grown on the farms will impact the cow production and cow health even. But what is less certain is how the feed quality will impact the manure nutrients, which will then impact feed quality the next year. And so are there interactions between years in terms of the forage quality from maybe a dry year? How will that influence forage quality the next year because of what is coming out of the cow in terms of the manure nutrients? And yeah, so things like that, being able to compare farm systems on different environments. So different crop choices, different choices of crop rotations, whether you're growing legumes and corn, or just corn, or corn and grass on your farm. Are there certain environments in terms of the climate and also the soil composition that would make one choice more efficient in certain areas? Those are the kinds of questions we're hoping to answer.
So I assume that with those kind of objective functions, of course, some kind of some constraints, you're probably trying to derive some optimization solutions in terms of your decision variables. So what are the key decisions that at different levels of dairy farm management? What are the key decisions that you are trying to optimize?
So I'd just say, first of all, to managing a dairy farm requires a lot of decisions, right? So we are looking at, of course, optimizing production. So that a key variable in that is ration formulation. So trying to find the best composition of feeds for animals on a varying basis depending on the stage in their life cycle, the stage in their lactation, and then also the available feeds. So depending on what they grow on farms, and then what the market determines as is available to be purchased. So that's definitely a key factor that we're hoping to understand. And of course there are animal models that can answer that question as well, except they're not looking at optimization in terms of the system, right? They're optimizing for producing the most milk at a cow level instead of looking at it from a whole farm perspective. So moving past just maximizing milk production, we're also looking to reduce environmental impacts in reducing greenhouse gas emissions, or of course is an important goal. But in dairy farms, it's also important to look at some of the water quality impacts that, like you mentioned. So finding ways to minimize ammonia emissions and leaching and runoff. So those are some of the goals that we're working towards in terms of system optimization. I'm trying to think of other decisions. So from a herd management perspective, there's also some important decisions that are difficult to answer without considering the whole farm system. So deciding when to keep an animal in the herd or to sell the animal is an important decision that impacts the farm for many years, right? If you think that an animal might stay on the farm for 5 years and go through 5 lactations, deciding when it's time to cull that animal or remove it from the herd is.
And it sounds like a life cycle asset management. It's
asset management. I haven't put it in that terms, but that's what it is. Yeah.
Yeah, it's kind of interesting because when I was looking at the transportation, for example, like a city, it's like a city school district. They maintain these kind of school buses. The school buses, different ages of school buses, right? Their performance, their emissions, and they need to also decide, okay, when to sell these and when to keep these. So that's very interesting. So I think, this is probably not very closely related, but I think the other day when I was driving and I was listening to NPR, they were talking about this, and then recently people are talking about this new Green Deal.
Yes.
Right, new Green Deal, and exactly. I think the example that the people were talking about, they were exactly using about like the red meat, and example they were talking about. Oh yes, this new Green Deal seems to paint a very good picture. However, how feasible is it going to be? Because I think from life cycle point of view, there were studies that show that on a weekly basis, if a household just once a week, if they switch from red meat to vegetable, on a yearly basis, they can reduce greenhouse gas emissions like they drive 4,000 miles less a year. So what's your view? We don't want to be political at all. But I'm just curious what your views are regarding this because these dairy and cattle farms, their positions and also their potential interests that especially when you're also looking at climate change. So how the dairy and the cattle industry as a whole is looking at these kind of climate-related issues.
I would say that agriculture and dairy producers take it seriously, and our farmers are the original stewards of the environment, right? Because their livelihood depends on the environment. But then also that there are greenhouse gas emissions from agriculture, and from cows especially. They have that rumen stomach, that rumen digestive system that produces methane. And there's some opportunity to find feed additives that will reduce that, but so far I operate under the assumption that cows produce methane, and that's a natural part of their digestive process. As far as how that factors into what choices we make as a society and how we feed, I think that's a really difficult, or how we feed ourselves, that's a really difficult question, right? Because the concern that I have is that there are a lot of different ways to look at the problem and to approach the comparisons in terms of one diet versus another. And I think for the studies that get a lot of popular attention, they tend to be on the side of the findings where we should drastically reduce our meat consumption. But I know I can easily point you to another study that says if we took out all animal agricultures, we would only reduce our greenhouse gas emissions by 2%. And we would also have to really change how we eat and possibly not get enough of certain vitamins and essential nutrients. So it's a really difficult question, and I don't have an answer. But I will say that I think that a model like the one that we're working towards is something that we talked about, scales, right? Is something that if we were able to simulate different management practices in different environments, we could potentially get a more accurate estimate of what greenhouse gas emissions are, rather than kind of the summary statistics that use pretty simple emissions factors for a very diverse farming system. I also would say I did during my postdoc I did a simulation exercise where I simulated improving the efficiency of feeding protein to cows, and when you improve the efficiency of converting feed protein into milk protein, then you reduce the amount of nitrogen that's in manure. And when I applied that to that high efficiency scenario to New York herd, for example, so simulated reducing manure nitrogen from all of New York's dairy cows, lactating dairy cows, the equivalent greenhouse gas emissions reductions from that nitrogen not going onto the fields was a pretty significant reduction in nitrous oxide. If I remember correctly, I think it was the same as taking 40,000 passenger cars off the roads for a year. So there's a lot of opportunities like that. I'm not saying that I don't support any diet changes, but I don't think that the solution is going to be a simple one, and I don't think they're proposing that in the Green New Deal either, but I think there's a lot of opportunity for improvements on the production side and then also from the consumer side.
I very much agree with you, and I really like the point that you made. As researchers, the key thing is here is it's really science is one thing, and policy is another thing, right?
Mm-hmm.
Of course, we want to connect science to policy. However, from science to policy, there is a long way. Like public opinion, how the public will view these things. However, I think your point, it's made that as researchers, we have the responsibility to develop such kind of models and tools that will enable the stakeholders, decision makers, and general public to at least look at these things from a holistic system point of view. For example, your model, that model you developed, it's not only trying to optimize the nutrition management for the dairy farm, and also you consider the externality, of all these activities. So that's why I think it's really in developing these models and equip the society with the capability, and that's really a very important responsibility that we can take on.
Right. Yeah, I definitely agree with you. We are charged with providing knowledge that will support society, and I think especially being from the land grant part of the university, that is within our mission, and supporting these decisions at the policy level and also at the industry level. For sure.
Yeah, I noticed that you have a recent publication where you wrote a short communication to identify challenges and opportunities for improved nutrient management through the U.S. Dairy and agriculture systems. So what opportunities and challenges did you identify in that study?
Well, so that study was based on the USDA survey, and I think was more of a thought piece. There was a lot of authors and contributions to that. I think what I got from that study was that the opportunities are to capitalize on the diversity of systems and to find the combinations of management factors, animals, types in terms of the genetic adaptations, and fit them to the different environments where we raise dairy cattle. There is a lot of diversity in terms of how we raise dairy cattle, but that spans across all of the different regions. I think we need to work towards tailoring our management and genetic improvements to specific environments. That was my takeaway from the study. The other takeaways, I think, are that there's large opportunities in terms of improving manure management, and that is really an important topic because there's lots of great technologies coming out, but there's not a lot of incentive for farmers to adopt those technologies. Because they are not economically feasible at the moment, and so finding ways to either incentivize them or make them more economically feasible for farmers at the moment, I think would definitely improve whole farm efficiency and nutrient management, so that they're not losing so many of the nutrients that they purchase in feed and fertilizer. They're not lost through emissions or runoff or leaching.
In this kind of agriculture and animal farm production, this is really critical to sustain the society by providing all these good nutrients. Not only nutrients to the animal, but of course these nutrients provided to the human beings, right? So in this process, and especially you are developing these kind of systems models to optimize the operations of these dairy farms or cattle farms, and of course you have all these object functions. I'm just thinking it's kind of this is again I don't have any negative think at all, but I'm just curious, because when we human beings, when we try to optimize something, especially for a given purpose, for example, if we are optimize the farm or dairy cattle farm production with an objective function to maximize the farmer's profitability, right? So, and then would that be possible for us to lead to some kind of actions or decisions which doesn't seem kind of, say, ethical?
Sure. Yeah.
For the animals, especially with your background in animal science, a lot of people talk about animal rights, because I'm not that far yet.
Right. Yeah. That's a great question, and I know when in our model development talks and kind of the way back when we were initiating this project, we talk about identifying trade-offs more than optimization, because like you said, if you maximize milk production for a given system, there's bound to be some other negative impacts. I tend to think about it in terms of the environmental system trade-off. So I think about, if there's a certain animal density, for example, so a certain number of animals per unit of land that would maximize production, what is the actual environmental impact? So what is, in terms of the kilograms of nitrogen that's going to wind up in the groundwater? Is that an acceptable outcome in terms of society and in terms of water quality to achieve that level of milk production? Or are we better off not optimizing the milk production, not maximizing milk production, and achieving a lower or better water quality standards? And so, ideally, working towards some sort of multi-objective optimization, but in terms of the complexity of the system, the dairy system, I need definitely to collaborate with some people that are more familiar with or better at developing those optimization functions than I am, to achieve that degree of optimization. But certainly there are trade-offs with any goal that we're trying to reach. If you're interested in the kind of animal health or animal welfare in particular, I think it's an important point to consider. And I'm trying to think. I don't think we have kind of plans for animal welfare metrics, but they haven't been included in the model yet. We currently just have health, which is, connected to animal welfare, but not the whole package. So I think it certainly is something that needs to be considered, and especially if we really are working towards sustainability, we have to consider that social component as to what is socially acceptable in terms of how we raise our animals. But as from my point of view currently, the milk production levels that we see from animals right now are not negatively impacting their welfare.
That's very good to know. And also I appreciate, I think you, when you answered my question, I think you made a very, very good point. I think that's actually one of the key, probably, philosophy of system engineering. I think you said that we are not necessarily trying to optimize. We are really trying to do trade-offs. I think that's actually a very beautiful, I think, description of one of the elements that is key to systems approach, right? It's really, we're not kind of single-mindedly optimizing something. We're really making trade-offs in choosing those different alternatives. I think we are kind of probably running out of time, but I would like to probably conclude our conversation with by asking you a question about. I think you did your undergrad education was in animal science, and then you went on to Davis, and then you postdoc with kind of soil and dairy farm systems. So none of these disciplines per se, when we first heard it, none of these disciplines per se are really like systems. But I was curious, how did you kind of guide yourself to pick up all these different systems, model, and tools, and develop your systems views and visions? The reason I'm asking this question because our system engineering program, we have a Master of Engineering degree program, and also we have a PhD program in systems. So I think kind of your experience and also your insights would be very helpful for our system student to also learn how, like in their future development, they can take some kind of tips or insights from you in guiding their own research and their own career development.
Part of my the reason that I have developed this systems thinking is because of a personal interest in why I went back to school, and so I went to graduate school because of the experience I had in international development. I was working in Southern Africa and trying to improve agricultural development system. Trying to improve agricultural development. But I was really disappointed in that that development model, because it seemed like there were solutions coming from whatever development organization coming down and being applied in these systems and areas that weren't well suited to whatever the solutions were. And so because of that, I had that kind of hands-on experience of this mismatch between the information and the research and the prescriptions for an agricultural system not working for the actual physical system. And so the reason I went back to school was to learn how to think more holistically about these agricultural systems and how to develop better recommendations for the for the I don't know, yeah, for the agricultural system. I'm trying to think of other words besides system, but so in my, even though I went to a PhD program to study animal nutrition and ruminant nutrition modeling, it was always with the goal of being able to apply these modeling techniques to a larger scale, right? So, and so I think from there it was just personal interest in learning how different parts of the dairy farm are connected, and learning how to account for those connections and variability in a rigorous manner in computer models and simulation models. What would I tell them in terms of tell them about what's important in systems engineering?
Yeah, and also kind of like their own development, and especially when they're at school, when they're still now in their program, how they might be able to take advantage of the college environment and university environment, and also especially with your case, it's really your exposure to the real world practice. Kind of how should they develop themselves to make their work more impactful to the society.
Right.
Yeah.
So I think starting with identifying a problem, so figuring out where the knowledge gaps are, I think, and so where we actually need models or predictions, or where we don't understand why something is functioning the way it is. I'd always like to start with the problem and then work backwards. The other thing I would say is I think it's really valuable to kind of get in and get your hands dirty in terms of trying to piece together the elements of the system yourself. Operate with that the adage that all models are wrong and some are useful, and so starting with a simple model just so you can break down and simplify the whatever you're trying to simulate, and piecing it together, and that can also often be illuminating in terms of where our understanding of the processes are not adequate, and where we actually need to go a little bit deeper and be a little bit more detailed in how we represent that process. And then I'd say, if they are working with a real world system, and whether that's transportation or dairy farm, I think there's a lot of value to be gained from going out and physically experiencing that system. So sometimes just being there and seeing with your eyes the way that it's happening can be valuable.
Beautiful. I think kind of if I may summarize, it sounds like I think you're telling people kind of identify the real problems and get your hands dirty and think systems. I think that's really very good advice, and I believe a lot of people will benefit from this. So Kristan, thank you again. Yeah. I think we'll get you ready for your talk.
Thank you. All right. Thank you
very
much.